Our next guest came to us from San Francisco yesterday, and he's still a little bit jet lagged, but he's ready to talk about authorization rails. Ladies and gentlemen, please welcome Yatish Mehta.
Cool. Thank you, everyone. And yeah, welcome to my talk. No pun intended. Topple the power of Rails authorization. And yes, the pun is intended. Cool. Before we start, I have a simple trivia question. What should we put in the place of the question mark so that it prints both the statements? And I have a book giveaway.
You could fork.
No.
Okay.
It's way more simpler than you guys think. No. You want both the sentences to be printed. So the output should be both. I like Sarnik, I like Pagdik.
I think you could do if puts I like Cernic and false.
Yep, that is correct. But we had two people who answered that question, so I'll find another book for you. Cool. Yeah, my name is Yatish Mehta. I live in San Francisco, California, in the States. I've been a Rubist for more than 10 years. I'm active on Twitter, GitHub. I'm the tech lead at Asana for authorization. If you don't know what Asana is a work collaboration platform to manage your projects, your tasks. We are based out of San Francisco as the HQ, but we have an engineering office in Warsaw, and we are hiring. So feel free to talk to me after the session if you're interested. Cool. Let's start with authentication and authorization. Like, these are the terms that people often get mixed up. So authentication deals with who you are. It makes sure the user is what they claim they are. Username, password, SSO, SAML, these are the terms that are related with authentication. In Rails, we'll use gems like device, raw-auth to manage authentication. Authorization, on the other hand, deals with what the user can do. What actions, permissions are allowed for this user. Now, since I'm traveling, a good example is passport is for authentication, but the visa stamp is for authorization. So let's talk about authorization Rails and like the different approaches with which we do authorization. Let's start with the basic implicit authorization. This is an example of an implicit authorization. We fetch the project. We fetch the project that is scoped to the current user. And if the project exists, we allow the user, otherwise we render unauthorized. Technically, there's no explicit authorization check, but our query scopes make sure that only the user who has access to the projects or projects that the current user owns are shown to that user. So there's no authorization as a framework or explicit check, but our queries and scopes kind of take care of that. Again, it's simple to implement, but now we have a business logic and authorization rules combined together. As our app grows, it's difficult to manage your authorization logic this way. So what's the next solution? You have the can gem It allows you to create an ability.rb file where you define all the rules and permissions for the user. So in this example, we've defined the read permission for the post resource for the user. And then you can check the permission in the controller using like the authorize method, and also check it in your views. Simple, right? But as your app grows, the ability.rb file also grows and becomes totally unmanageable. This is a 60-line snippet of code from an open source ability.rb file. Now just imagine what would the whole file look like. This, even if you can't read it, is an example of a real production app ability file, which can grow even from thousands of lines. Now your permissions, you could also have permissions which depend on each other, and that makes it really difficult to refactor them, because you have to make sure that refactoring one permission doesn't affect the other unknowingly. So what do we get with can? We get separation of concerns. All our authorization logic is in a single place. But again, as the app grows, ability.file keeps growing. That's not something that's scalable. So what's next? Pundit is the most popular authorization gem in Rails. There's also action policy, which is like a revised version of Pundit with additional features, but it has the same structure, the same philosophy. So Pundit provides the concept of policies. You can define a simple Poro class with your resource to define the permission. Each instance method is a permission check. Since it's plain old Ruby, you can define any logic within the permission method. So this is an example of like the update permission and some logic inside that. Again, similar to can, you can use it in the controller and in views. So kind of let's build a policy for an actual kind of a real use case. So let's build an authorization policy for a project management app. So the features are you have to organize like work with projects and tasks. Tasks can be part of multiple projects. You can have users that get added to the projects with admin, editor, commenter roles. You can even add the whole teams to projects with the same roles. So either you add the users directly or you add like the whole team, engineering or marketing, to the project, and then associate them with the same admin, editor, commenter roles. And again, users can be part of multiple teams. Just a second. Cool. So this is kind of the visual representation of our use case. You have users, projects, tasks, teams. Tasks can belong to multiple projects. Your projects can have users, can have teams, and then your users belong to a team. Let's define the permission for who can edit a task. The rules for this are if you're the creator of the task, or if you're an admin or editor of the project, you can edit the task. And you can be an admin or editor either directly or through a team. So how do you go about writing a task policy for this? And we want to write it for like who can edit the task, right? So you'll define an update permission. The first rule was to check if the task is created by the user, so you're checking for the creator. Then you'll check if you have admin or editor access directly, or then you have admin or editor access through a team. I mean, the end of the code is cut off, but that kind of the top method, the public method, gives you an idea that if any of these three conditions are true, you are allowed to edit the task. Soon your PM comes in and decides to add a new use case. If the task is sensitive, then only admins of the project can edit the task. So you go back to your code and be like, okay, I need to modify my policy. You're going to check first whether the task is sensitive, then only allow for admin access either directly or through a team. If it's not, you just use the old path. As you can see, it started to increase complexity. And let's see what are the limitations of Pundit as the app grows. The first is refactoring. It's really difficult to refactor a permission since changing one permission can impact upstream and downstream permissions. You have to be very carefully navigate the code through the policies to make sure there's no unintended impact. Like for example, if you change the definition of editor access, there could be permissions upstream that are using it, and you want to make sure you don't have any unintentional impact. There's no automated way to find these dependencies, so you have to navigate through the code to see what it depends on. Next is performance. When calculating the permission, you'll have to add or load intermediate objects. You can optimize the code, but it's easy to fall for n+1 issue here. I know we spoke about n+1 as a feature, but normally it's not. You can still optimize the code, but it's easy to fall for that trap. You cannot cache the result of the evaluation between requests. Since the permission logic is a black box, you have to evaluate the permission logic for every request. Fun fact, Figma recently mentioned in their blog that around 23% of their SQL queries are related to access control. So how do you check why a user was not allowed? Normally, you will get into the Rails console, load the user object, load the task or the record, and run that permission to see which component was false. In the same situation, you need to know, which is more dangerous, you need to know why the user was allowed, if it's a bad actor or unintentionally, if they got access. There's no easy way to audit or debug these permissions. There's no easy way to find out why the user got or did not get access. And finally, since Pundit doesn't store any data, there's no way to identify what users have access to. So there's no way to request, hey, give me the list of users that have this permission to a resource. Or, hey, give me the list of users that can edit this task. It's always the opposite, where given a user, given a task, it's going to return whether I can edit or not. So what do we do? Is there a better way to model our authorization logic? And yes, there is. There's fine-grained authorization, FGA. It's also called as relationship-based access control. This is based on Google's Zanzibar project. Google put out a paper about the Zanzibar project and how they manage authorization, a distributed authorization across apps for all their products. So the way FGA or relationship-based access control works is that you're storing relationship between entities as these tuples. They're also called as access control lists. So what you're storing is user A, where A is the identifier, has a relationship of editor with project X. So you're going to store these relationships in a subject relationship object format. And this is what your authorization data would look like, right? You would have a collection of these tuples and with the relationship with it. The other way to look at this data is it actually ends up being a graph, because a subject in one tuple could be a resource or an object in another one. So it's a graph of entities connected to each other via relationship, and the nodes being the entities and the relation being the edge. So this is your authorization data, which is static, which is stored. Then on top of this authorization data, you define rules for your permissions. Again, it doesn't matter if you can read this, but this is like the rules which are defined for this graph on how to navigate this graph. What paths are allowed for this permission? There are multiple FGA providers, and each one of them have their own DSL, but the idea is the same, where you're kind of defining a model, defining a schema, defining rules for your permissions. So in this world, checking a permission of whether user 2 has edit access to task 1, rather than checking, hey, does it have access? What you're saying is there a path from user 2 to task 1 in this graph based on the rules that we defined in the previous slide? And if that path exists, then user 2 is allowed to edit task 1. So how do we implement FGA or relationship-based access control in Ruby on Rails? I created a gem called Granity to support fine-grained authorization in Rails apps. So let's look at how it works. You add the gem, you install the artifacts. It's going to create a migration and a model. This is where you're going to store the tuples. Once you add the gem, we need to define the authorization model or the authorization schema. So you define this, it's going to be in your initializer. But this is how you would define. First, you'll go through the entities of your app. So we're defining like resource type user, which is one entity. Then you have another one, which is team, so resource type team. And then you define a relationship between them. So for this one, I'm defining a member relationship. So what this says is the team object or the team entity and the user entity are related with the relationship name called as member. Similarly, we define the project entity. It's going to have a relationship with the user, a relationship with the team, and like multiple types of relationship, admin, editor. And again, if you have more access controls, you'll add them here. You define the task entity. Now it's a relation between project and a task. And for the creator, it's between the task and the user. So again, you're taking those graphs and edges and you're defining that in the schema, which is again, Ruby code. So it generates a graph object out of it. Once you've defined the relationships, you can define a permission. It has like a DSL of include any and include all. So you can have like nested and or logic to combine your rules. So what in this case, it's saying that, hey, if any of these conditions or any of these relationships exist, then you're allowed to edit the tasks in that project. In the same way, you're defining one on the task object, saying that, hey, if you're the creator or if you can edit the project tasks, then you can edit this task. Again, you can use either a relationship or you can use another permission. So in this case, we're using a permission which was defined on projects. So once you've defined the schema, it's time to create those relationships. It's time to create those tuples. Again, you're going to create those relationships based on your flow. So every time a new user is added as an editor, you will kind of call this in your code path. Again, if you add or remove or modify, you would do the corresponding changes. So in this case, in my code path, wherever I'm adding a user to a project as an editor, I'm going to include this so that it creates that tuple for my authorization data. And finally, how do I check my permission? Again, it's a simple check permission where I pass in the user, pass in the task, pass in the permission name. It's going to use my rules, go through the authorization data, and if the path exists, it means yes, I'm allowed to do it. And if no, then it's going to return false. Again, like can and Pundit, there are helper methods so that you can kind of use it in a concise way rather than passing all of those attributes. So how does this win over the previous approach, right? What are the advantages of FGA and Granity over our previous approach? Since the authorization model is defined as a schema, you can easily check for dependencies. You literally have a graph object, so you can query it, question it, saying like, hey, give me the permissions that they are dependent on. So when you're refactoring, you're really confident about what other permissions would get impacted by it. Performance. There's no intermediate object loading. The tuples navigate through IDs. So it's just when it's navigating, it's not loading the team object, it's not loading the user object. It's just going through those tuples. Granity also has smart caching. So you can tell it to cache results between requests. Since it knows the dependent nodes, if it can cache the result, and if there are no changes, it's just going to return the result from the cache. And if you add a new node, add a new edge, it knows its dependencies and it can invalidate those results. So technically, you don't need to evaluate the permission for every request. Auditability. Now you can ask it, along with the permission result, to also return you the path. This makes debugging easier, and you know why a particular user got access. So in this example, you could get access to the task maybe through a team, or maybe through direct access. Since you have the whole path, you know why the user got access. Reverse lookups. Because you're storing these relationships, you can actually ask the opposite question of like, hey, give me the subjects for permission edit for this resource. And it'll give you the list of users back. Again, this is, I've put a star on this because there's a caveat. It doesn't have pagination, so it depends on what your authorization model is. It could load all the users. So you want to be careful with this. Yeah, finally, we spoke about FGA in Rails, but there are many external open source authorization as a service providers for fine-grained authorization. So you have OpenFGA, OddZ, OSO, Permit.io. All of them are based on Google's Zanzibar project. And they're pretty advanced. They have like a playground. You can set up the model, test data. So I would highly recommend to like kind of go through these just to understand FGA, understand authorization as a service, like just the concept of relationship-based access control. If you have used, or if you use an external service for this, this is how the flow would look like. Your authorization data and model would live in the auth as a service. So every request, you would have to call that service. So let's say I call the update endpoint. It's going to first check, hey, this user, this resource, does it have access? Returns me back the answer. And then depending on that, I'll either return the result or say you're unauthorized. Again, these authorization as service projects are like really optimized, cached. They kind of promise like single-digit millisecond latency. but still it's an external service. This is very useful if you have like a distributed system microservices architecture. So yeah, just to summarize, you start simple with Pundit. You add something like Granity for fine-grained authorization. And then once you reach like a distributed, a truly distributed system, you would consider something like the options that I gave before, authorization as a service. Yeah, that is it.
Any questions?
Yeah, thanks for the talk. I just didn't realize how exactly would you model the sensitive task case.
Yeah, so you would create a new entity called as sensitive task, and it would have a relationship with task. So if it's a sensitive task, you would have a relationship with the same IDs. So on the left-hand side, you would have an entity called a sensitive task. Right-hand side, you would have the actual task, and the relationship would be something like is sensitive. Even if it's not a model, within your authorization model, you can create a new entity out of it.
Okay, understood, thanks. And the other one is how actually difficult is it to keep all these relationships in sync?
So that's a challenge because technically what you're doing is you're taking your belongs to many foreign key relationships and you're moving it out or you're duplicating it from your model to this normalized entity attribute value kind of a table, right? Like imagine if all your foreign keys, all your many-to-many were in a single table. That's what you're doing. So that's, you have to manage that explicitly, where after create commit, you have to make sure you're making an entry in the authorization model as well. So yeah, but at least if it's within the monolith, it's within the single transaction. When you use auth as a service, it has to be synced between your Rails app and the external service. So yeah, you have to manually manage those relationships.
So you kind of have to have a logics that checks the, you have to have a logics that, duplicated logics kind of, that checks if you do have this.
Kind of, yeah. But you would do it only for relationships that you kind of care about for authorization.
Yeah, great talk. I've seen some of these authorization as a service providers, and it's cool to see a gem to do it locally. I was curious though, in Pundit, you have the ability to define scopes in your policies as well. When doing this relationship-based access control, what is the pattern that you reach for to sort of define the scopes for the different parts of the app?
Right. That's something that's, I mean, when you have relationship-based access control, you don't have that, but you have to like explicitly query it. Like that's something that's missing. In Pundit, again, you could have like just a black box of logic that you can add, where here you have to be like, it's very constrained. You have to define that relationship. I can't just have any Ruby code to be checked. So those are like constraints with this, for sure.
Any other questions? Okay, thank you very much, Yatish.
Awesome, thank you.